Hello, this is Mr. Huff, and we need to have a real quick review of the dimensioning guidelines. And if you look at Activity 7.1, More Dimensioning, we are going to be talking about dimensioning standards, but we need to review our dimensioning guidelines. So I'm putting together this quick presentation to remind you. You should already have a copy of the guidelines in your notebook from earlier this year. So I've got about 20 ideas we need to go through. This means that when you dimension, the dimensions should be the actual values to reflect the actual size, not the scaled size. So let's say you have something that's 10 feet long by 20 feet tall, and you have to scale that down onto your paper. This means that the dimensions need to be 10 feet tall or 20 feet by 10 feet, not the small size that fits on your paper. The dimensions need to show us everything there is to know in all three directions, the principal directions, height, width, and depth. When you're dimensioning, your largest dimensions, your height, width, and depth for the overall part need to be placed the furthest away from the object. Generally, what we are going to do is start from one edge and measure a small measurement, then a middle measurement, and then the greatest measurement. The higher the number is, the further from the part it needs to be. You do this so you don't cross extension lines unnecessarily. You need to include all the dimensions to describe the part. You should use dimensions and place them in such a way that no dimensions are assumed and the person looking at the part does not have to do any calculations to understand the size of the part. Do not include unnecessary dimensions. So if you've already described it, you don't need to do it again. If it's not critical or, don't just start throwing a lot of extra stuff on there just to make it look busy. Dimensions should not be duplicated. So you don't want to present the information in two ways. We're going to be looking at showing dimensions in coordinate and angular. You use one or the other. You do not use both. We are using an electromechanical standard, and we are not going to use chain dimensions. Chain dimensions are to be avoided. You are going to use datum measurements instead, so don't use chain dimensions. If you have two views of a part and one shows a straight line and one shows a profile, you're going to put your dimensions on the view that has the best profile. I'm not even sure how you would do this, but apparently someone has done it. So the dimensions should only be associated with one view. You don't use extension lines to connect two different views. I am not even sure how to do this in Inventor, so I think it's going to take care of you here. There is an area between the top, front, and right views. That's where you need to place your dimensions, if at all possible. That's your preferred area. Sometimes it's not practical. You would have to put extension lines across the parts, and you don't want to do that. So use that as your preferred zone, that kind of plus that appears in the center of the page between the views. That's where you want to dimension primarily. I would say never dimension to hidden lines. Do not do it. And on this one, the level that we are going to be working at, there is not a reason at all to put a dimension on top of a part. Always have your dimensions outside of the part. Because so far I haven't ran into an instance where it was necessary for you to place the measurement on top of the part. Use section views and detail views if you feel like you have to do something like this. Don't try to avoid crossing things, crossing the lines. You want to make ultimately the goal is this. You want to be able to look at the drawing and see the dimensions clearly, and if you aren't organized, you can end up with a jumbly mess. You are going to have to cross things, but if you can do it in a way that you don't have to, that's going to look a lot cleaner than a whole jumble of crossed dimension lines. But there are some parts that are complex. It's very hard to keep it clear, so we'll look at some ideas to help you make sure you're not doing this. This is a guideline. Alright, so what this is saying is when you have your dimension number, you want to place your extension and leader lines so that they don't cut through the dimension number. When you do that, it becomes difficult to read the dimension number correctly. So that the dimensions should not be cut through by other parts of the dimensioning process. Leader lines need to point toward the center, and they should not be vertical or horizontal. You always have those at an angle. When there's multiple leader lines, let's say you have a part that has got a lot of concentric circles, I usually start with the biggest one at the top and go down the page, getting smaller and smaller so that they're organized. What this is saying is if you have dimensions, they should be centered between the arrowheads. When you place a dimension, Inventor does a real good job of doing all of this for you. However, if you have several dimensions that are very close together, you will offset those so that they're easy to read. And this is only whenever the dimensions are so close that it makes them difficult to read. So you would offset them one a little bit. Push one to the left, push one to the right. And again, Inventor will take care of this, but if you have a circle, it's going to have a diameter, and if it's an arc or a portion of a circle, it's going to be dimensioned by radius. Whenever you're dimensioning a hole, it needs to be dimensioned to the view that shows it as a circle. Like if you've got a hole that's cut through, a circle that cuts through a part, you wouldn't use a linear measurement to describe that hole. That's another way I would say this. Use the circular dimension tools to define holes and arcs, and use the linear tools to describe boxes and lines. Don't use linear measurements to describe a round feature. Whenever you have holes, you need to also place a center line and a center point. That makes it easier to understand where the middle is, because for machining, the center point is the most important piece of information that the machinist has. And then secondly is the diameter. Okay, but that location is crucial. And that is a quick review of the 20 ideas for dimensioning. And that's all. Thanks for watching.